Hello and welcome back. Now we are moving our tank forward and backward, but we have no way to actually steer the tank. So in this video, we're going to work on actually turning the tank using something called local rotation. This is the rotational analog to add actor local offset. Now, add actor local offset had multiple input parameters, and we only passed in the first one as the other three were optional. But one of those other three had to do with sweeping, and we're going to discuss a little bit about sweeping before we continue implementing rotation. So I'm back in the documentation for add actor local offset. So let's take a look at these input parameters once more. The second one is called bsweep, and it's a Boolean. Now, if we scroll down a little bit more and read the information here for bsweep, it says whether we sweep to the destination location, triggering overlaps along the way and stopping short of the target if blocked by something. It also goes on to say that only the root component is swept and checked for blocking collision. Child components move without sweeping. If collision is off, this has no effect. So let's talk about what this means. Now, in games programming, sweeping is a technique done by the engine as long as sweeping is enabled. If we have a moving object, such as a sphere represented by this circle, each frame, as this sphere is moving, the engine is performing sweep checks. This means it's checking to see if that move for this particular frame would have resulted in an overlap between two objects. So I have this block here represented by this rectangle. Now let's just consider that these are the only two objects in the world. So while sweeping is enabled, as the sphere is moving towards the object, the engine is checking to see if these two objects are overlapping. Now as the sphere continues to move, let's say during one of these frames, the sphere would have moved such that it's overlapping the other object. Now, what sweeping enabled does is the engine will detect this overlap and move that sphere back for that particular frame so that it never actually penetrates the object. Now, we never actually see the sphere penetrate the object. The engine catches that overlap before the movement is actually implemented. So the result is that we see that the sphere stops just short of overlapping. So if this rectangle were a wall, for example, the sphere would stop at the surface of the wall. That is what sweeping achieves for us. Now, the documentation says if collision is off, this has no effect. So collision has to be enabled in order for sweeping to work. So back here in tank.cpp in the move function, here's our call to add actor local offset. And if we want, we can pass in another input parameter here, the second one being the sweep Boolean. So we can pass in true here. So let's compile this and see the effect of enabling sweeping. Now, if we press play and we attempt to move through a wall, for example, we'll see that we move right through the wall. So something isn't quite working here. Now let's look at what that root component for the BP Pawn tank is. Recall we used the capsule component for the root. So with capsule component selected in BP Pawn tank, let's go to the details panel and scroll down. And we'll see here a section called collision. And here we see collision presets. And it has a drop down, so let's expand that. Now, collision presets can be set to any number of options, and by default, we see overlap all dynamic. Now, depending on the version of Unreal Engine you're using, you may see something else here, but we can change this. If we select the drop down and choose block all dynamic, then the grayed out options below change. Remember, we were on overlap all dynamic. And here we see three columns of checkboxes. These are collision responses, and the column to the left show a list of collision object types. So any given component has its own collision object type. Notice we can see the object type for the capsule set to world dynamic. And when we changed collision presets to block all dynamic, you'll see that the collision responses are all checked to block in response to all other collision object types. So let's press play and see what happens when we try to pass through things. You'll see that we stop just short of overlapping with the other pawns. Now, if I move the tank so that we can attempt to overlap with the wall and sort of go around the other pawns, now if I press play, I block the wall as well. So this collision preset, block all dynamic, sets the collision response to block all other object types. And you can always see the collision object type of a particular component by selecting it in the Components panel and scrolling down to the collision section in the Details panel and opening the dropdown for collision presets. I have the base mesh selected and its object type is World Dynamic and it's set to block all. So now we see that sweeping is working since we set our collision presets for the capsule comp to block all dynamic. And we saw in the documentation that only the root component is swept and checked for blocking collision. So it doesn't really matter what the other components are set to. We're only checking to see if the root component is blocking something. Now, one issue that's tripped up some students is that they cannot move as soon as they set the capsule to block all dynamic. Now, one reason for this could be that your capsule is overlapping with the floor. If the capsule's overlapping with the floor, you won't be able to move because the engine will not allow your tank to move if the capsule component is overlapping with something that it's set to block. So an easy fix for this would be to make sure your capsule is not overlapping with the floor. Now you can go into your BP pawn tank and make sure that your capsule is just above the wheels here. I'm going to go into orthographic view and select my base mesh and just bring it down so the wheels are just below the capsule component. So now if your mesh is just on the floor and the capsule is just above the mesh, you should be able to move around. So I'm going to hit play and there we go. So now that we have sweeping out of the way, it's time to start implementing rotation. Let's go back to our project settings. So we go to Edit, Project Settings, scroll down to Input, and in the Input section, we have our axis mappings. Now we've already taken care of Move Forward. It's time to take care of the next one called Turn. And Turn has D and A assigned to it, where D has a scale of 1 and A has a scale of -1. We'd like to use the D and A keys to rotate the tank. So in order to bind a function to the turn axis mapping, we need a function to bind. So we're back in VS Code, and I'm going to go into the tank.h file so we can create a function to bind to that turn axis mapping. Now I'm just going to call this void function turn, and just like move, it needs a float input parameter, and we'll call this value. So we've declared this function. Let's define it in tank.cpp, and I'm going to put it just under the move function. So I've given it a function body, and I need the class name along with the double colons just before the function name. Now we have a proper function. Now this isn't the only thing we need to do. We need to make sure that this function is bound to the axis mapping called turn. We do that in setup player input component, and we do it just like we did the move forward axis mapping. So we're going to say player input component. We're going to use the arrow operator and bind axis. Now, the first parameter is going to be the axis mapping name wrapped in a text macro. So we're going to say turn, as that was the axis mapping name. Next is the object we're binding the function for. We can pass in this. And finally, we pass in the function we'd like to bind. Again, we need the address of operator, and it's going to be a tank turn. So it's as easy as that. We've bound the turn function to the turn axis mapping. The only thing left is to actually do something in the turn function. Now we've seen that we have add actor local offset, but there's a rotational analog to this function, and it's called add actor local rotation. What this does is adds a local rotation to the actor, as its name suggests. And you'll see that there are two different versions of the function, one that takes an F rotator and one that takes something called an F quad. We're going to use the version that takes an F rotator. It's called delta rotation. And just like add actor local offset, it can also take a sweep parameter and the same other two input parameters as add actor local offset. And these last three input parameters are optional, just like add actor local offset. So instead of an f vector, we're going to pass in an f rotator. Now back here in the turn function, if we create an f rotator and we call this delta rotation, we'll see that if we right-click on f rotator and go to definition, we're taken to rotator.h, and we'll see three public member variables here of type float. Now, just like the f vector, f rotator has these three components, only instead of x, y, and z, we have pitch, yaw, and roll. Now, yaw is the component that we're interested in. It says rotation around the up axis, in parentheses around z axis, and that's the only type of rotation we care about, rotating around the z axis. That's how we can steer our tank. Now, I'm just going to point out to you that there are multiple constructors for the f rotator as well, and that the default, again, says no initialization, just like with the f vector. So we can use the one that takes a single float, and all components will be initialized to that float value. There's one with 3 float values, and you can take a look and see some of the others. Now, I'll also point out that there's a 0 rotator. And by the way, this is a static 0 rotator. That's why we can go back into tank.cpp and say something like equals f rotator 0 rotator. 0 rotator is a static member variable, and you can access static member functions and variables like this by specifying the class name with the scope resolution operator and referencing that static variable or function by name. That's what we're doing here with uGameplay statics. GetWorldDeltaSeconds is a static function, meaning we don't need an actual instance of the uGameplay statics class to exist for us to access that static function. It just exists already. Same with 0 rotator and 0 vector. So I'm going to close out of rotator.h. And we have this delta rotation, and it's initialized to a 0 rotator. Now, yaw, pitch, and roll are zeroed out just like x, y, and z are zeroed out for the f vector. So we're going to need to change that yaw component. So just like I did with our delta location in the move function, let's create some pseudocode for delta rotations yaw. We're going to want yaw to be set to value, scaled by delta time, of course, because we want this turning to be frame rate independent, but we also need some sort of turning speed. We can call this turn rate. So once we've set that yaw, then we can add that local rotation, which is going to rotate the actor according to the f rotator each frame, and that yaw will be scaled by value. So it'll be 0 if we're not pressing any keys, and it will have a value if we're pressing the D and A keys. So now you have a challenge. This is going to work just like adding the actor local offset. The only difference is we're rotating the actor now. So since we need some sort of turn rate for rotating the actor, you're going to create a turn rate variable. Make this a float and put it in the private section right next to the speed variable. Expose this variable with uProperty and choose the appropriate uProperty specifiers. Now in the turn function, you're going to set delta rotation. In particular, we care about the yaw component. Set the yaw value equal to value times our turn rate variable and also multiply by delta time. And then you're ready to call add actor local rotation, passing in this f rotator. Now for the second parameter, go ahead and pass in true for the B sweep input, since we do want to sweep when rotating. Pause the video and implement rotation for the tank now. Okay, so this is going to be fairly simple. We just need a turn rate variable. Now I'm going to go into tank.h just under speed and create float turn rate. Now you probably initialize this to some value, and that's okay if it's different than what I'm choosing. I'm going to go with 45.f and see how that works, but we're going to expose this to blueprints so we can change it while we're developing. Now I'd like it to be edit anywhere, and I'm going to stick it in the same category movement as speed. So I'm going to go ahead and steal this uProperty and paste it right here above turn rate, so it's edit anywhere, category movement. Now in tank.cpp, I'm ready to set the yaw for delta rotation. So we're going to say delta rotation.yaw, and we're going to set it equal to value times turn rate times delta time. And of course, we can get delta time with U gameplay statics get world delta seconds, passing in this as the world context object. So I'm going to paste that right there. Now, I know that my pseudocode doesn't exactly match. It's in the wrong order. Delta time is in the middle here. It doesn't matter because when multiplying 3 values together, you can multiply them in any order and still get the same result. So just in case you were wondering about that, the math will still come out the same if you multiply these 3 values in a different order. So don't worry about that too much. Now we have delta rotation. The only thing left to do is to call add actor local rotation. And we're passing in delta rotation. And for the second input, we're going to pass in true to enable sweeping when rotating. So let's compile this. All right, we're compiled. Now you may notice in a couple of the next videos that zero vector and zero rotator are missing from these lines. That's because I started off with these uninitialized and realized later that these should probably be initialized, at least with 0 values. So don't worry if you see these lines later looking like this, uninitialized. Keep your zero vector and your zero rotator, and you'll see that I catch this in a near future video. So don't worry if you don't see these initializations. They should be there. And we're back in the editor. Let's hit play. And I'm going to use the D key. And we're rotating. And the A key rotates me back the other way. And we can also move forward and back. So now that we can rotate and move forward, we have the ability to move around the world. This is a great milestone. Now I'm moving quite slowly, but that's okay because I can select my tank and I can search for the movement category and change turn rate to something higher, such as 90. So let's go ahead and hit play. And that's quite a bit faster. Now, if you think this is still a little slow, you can, of course, adjust these. So I'm going to select the pawn tank again. And instead of 400, let's make it 800. Why not? And instead of 90, let's go to, say, 120. Now, if I press play, I'm quite a bit faster. So this is looking really, really good. So looking back at the section plan, we now have a tank that can move throughout the world. That first bullet point is definitely checked off. And we're handling WASD movement. We're not handling mouse input just yet, but we'll get to that. But we're one step closer to making this game complete. So in summary, we learned what sweeping is and how we can enable that so that our objects do not pass through one another. We added an actor local rotation, and we did this implementing a turn rate that we could adjust in the details panel in the editor to make development a little bit easier. Great job! We're now moving the tank throughout the world. I'll see you in the next video.